All right, so let's go over the warm-up. So the first question was just to solve this equation that had -3 times x minus 1 and then 4 times x plus 1. So Brittany, what did you do first? What do you mean factored? Okay, so -3 times x and -3 times -1. So you distributed, you didn't factor. Actually, the opposite of factoring. So you distributed this in, you got -3x plus 3. And then did you do the same on the right side? Yeah. Okay, 4x plus 4. And then, Jenna, what did you do from there? Subtracted this constant 3, that one. Okay, so you had -3x equals 4x plus 1. And then what did you do? So -7x equals 1, and then what did you end up with x equaling? 1/7, but don't forget about the negative, so -1/7. Who else got that same answer? Okay, those of you who did not, do you know what you did wrong, or did we make a mistake? I think we did it right. Negative, positive, subtract. Yeah, looks good. If you didn't get -1/7, try to see if you can figure out what you did wrong. Okay? I'll leave that up for just a second while we start the next one. The next one said, out of these two expressions, find the least common denominator. So you have to think back to, if I wanted to add these expressions together, what would I do? I would first factor the denominator to see what factors they're made of. So the first one is just x plus 3. I can't factor that at all. But 2x minus 6, I can do factor out a greatest common factor of 2, leaving me with x minus 3. What that means is that both of these denominators are totally different. They have no factors in common. And so to use a least common denominator, it's going to have all of these factors together. So my least common denominator would be 2x minus 3 times x minus 3 times x plus 3. That would be the goal if I was to try to add these factors together. Now, finding a least common denominator is going to be crucial to what we do in the big chunk of the lesson today. Not the very first example, but all the other examples, you need to be able to find a least common denominator. Does it make sense what I did with that one? Okay, before we even jump into today's lesson, what if this first one was x plus 3, but also had an x minus 3 with it? Would I need to have my least common denominator have 2x minus 3s? Since there's 2x minus 3s total? Keegan's saying no, you wouldn't. If it occurs one time, that's good enough, because look at, now with the first expression, all I would have to do to make this have a common denominator with the second one is multiply by 2 top and bottom. Something like that. And then on this one, what would I have to multiply by to get a common denominator? If I wanted the denominators to match. Shannon? Yeah, the x plus 3. So identifying then, in that case, the common denominator would still be 2 times x minus 3 times x plus 3. Okay? And that concept's going to be really important today, along with being able to solve a variety of equations, especially involving a lot of parentheses. Okay? So our lesson today is actually going to be handwritten on your notes, so get out a separate sheet of notebook paper, and you can title it Lesson 7.5, Solving Rational Equations. And there's two goals today: solving by cross multiplication, and we'll talk about what that is, and then solving using least common denominator. And I would say the first one, cross multiplying, is going to happen maybe 1/6 of the time, so not that often, but it's still an important concept to teach and to be able to use because it's quick and efficient. And then using a least common denominator will be a good chunk of what we spend our time on. because using a least common denominator will work for pretty much every rational expression that you need to, or rational equation that you need to solve. So you can get the words from your book if you want them. I'm just going to say it. Basically, with cross multiplying, as long as you have a single expression on one side and a single expression on the other, you can use cross multiplication to solve. So I'm just going to show an example. If you have something like this, x over x plus 2 equals 10 over x plus 5. And it can be more complicated than that, but as long as the idea is you have one single expression here on the left and one single expression on the right, you are allowed to use cross multiplication. Who knows what cross multiplication looks like? Like if I was to take this problem and use cross multiplication, what would I do? Tori? Good. You would multiply 10 times the x plus 2, and then you would make that equal to, and you would multiply the x times the x plus 5. Now, doesn't that look a lot like the equation we just solved in the warm-up, right? So from there, it's pretty simple to go ahead and solve, depending on the problem. Okay. Using a least common denominator, you have to use if you have more than one expression on each side. So maybe if you have something like 12 plus x over x plus 2, I'll use like pretty much the same example we had before. If you have something like this, where you have 2 terms on the left and 1 term on the right, then you cannot use cross multiplication. And then we'll use a least common denominator. And I'm not going to talk a lot about what that looks like right now because we'll see some examples. Okay, but the big idea is these are our 2 different methods we have today. Every problem I give you, I want you to think about, can I use cross multiplication? Because that would be easy. And if I can't, I have to use the least common denominator method. So our first example, we want to solve the equation 3 over x plus 1 is equal to 9 over 4x plus 5. Once you write it down, I want you to think, can I use cross multiplication in this one? Or am I going to have to use that other method Ms. Roberts going to teach me that's not going to be very fun? Just a warning. So Betsy, what do you think? Do you think we're going to be able to solve this one using cross multiplication? Yes? Why? Good. There's 1 fraction on the left side. There's 1 fraction on the right side, so we can use cross multiplication. So let's go ahead and do that. I'm going to do the 3 times the 4x plus 5 first. So 3 times 4x plus 5 is equal to 9 times x plus 1. And I'm writing it out in that step because that shows what I did. If you want to actually multiply the first step and just do the work in your head, that's fine. 3 times 4x is 12x. 3 times 5 is 15. So we get 12x plus 15 equals 9x plus 9. And then from there, Jacob, what would you do next? Okay, subtract the 9x. So that gives me 3x plus 15 equals 9. And then what would you do from there, Rachel? Okay. So 3x equals 9 minus 15, so negative 6. And then that means x would equal negative 2. And then just go back and make sure that negative 2 is not a restricted value for this. That's one thing we need to make sure we're checking. If I plug negative 2 back in, I'm not going to get a 0 on the denominator, so I'm okay, because negative 2 plus 1 is negative 1, that's okay. Negative 2 times 4 would be negative 8 plus 5 is not going to be 0. So as long as this doesn't give me a 0 on the bottom, we're usually good. If you want to go ahead and actually check to make sure that you do get an equal expression, you can always plug that in and check as well. Does that make sense?